Good day everyone and welcome to Organic Chemistry Lesson 1. Organic molecules must have carbon atoms. Most of the time they also have hydrogen atoms and oxygen atoms, nitrogen atoms, sulfur and phosphorus atoms. So if you go to your periodic table, carbon, hydrogen, oxygen, nitrogen. That's the most common elements you'll find in an organic molecule. So organic molecules are everywhere. Literally, it's in the clothes you wear, it's in the food you eat, that vanilla ice cream, the medicine, an aspirin if you've got a headache, and then plastics, the pen you're writing with, and rubber. So organic molecules are important since they are everywhere. They've got unique properties because of the carbon atoms. Organic molecules all have carbon atoms, and they are special because carbon atoms always forms 4 bonds. This is very important. For organic chemistry, you need to know that carbons always form 4 bonds. They can be very complex, meaning carbons can form single bonds, double bonds, or even triple bonds. They can string along in long chains, or they can form short chains or branch chains. They can even form cyclic molecules. Carbon atoms mostly form covalent bonds. Why? Because a carbon atom and a hydrogen atom has similar electron negativity. Structural formula. This is important because in an exam question you might get asked to draw a structural formula. So what structural formula means is all the bonds are shown. So every carbon-hydrogen bond are shown in these molecules. Semi-structural formula means that carbon-hydrogen bonds are omitted. Therefore, only carbon-carbon bonds are shown, like in these molecules. So this is exactly the same as the molecule drawn on top, except this one is in structural formula and this one is in semi-structural formula. Condensed structural formula. Here you do not show the bonds, you just write the groups together. So here you have a CH3, there is the CH3, CH2, 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 CH3, CH3. Or you can abbreviate it by writing the 2 CH2 molecules then in brackets. In this molecule you have a CH3, then a CH carbon, and then you have 2 CH3 molecules. The next formula in a way that you can express structures is the molecular formula, where you only show the atoms. So here you just count the amount of carbons and you count the amount of hydrogens and you just write C4H10. This molecule can then either look like this one or like this one. Very important, structural isomers have the same molecular formula. Therefore, these 2 molecules are structural isomers of each other. Example 1. For each of the following, give the structural formula and the molecular formula. So for the first one, structural formula means show all the bonds. So there's 3 carbons, 1, 2, 3, there they are, 1, 2, 3, each with all of their hydrogen atoms. Remember, a carbon always forms 4 bonds. And then the molecular formula, where you do not show any bonds, C3H8. You just count the amount of atoms. B. CH3, there it is. CH2, there's that one. CH, there's that CH part, and now it is bonded to two CH3 groups. Here is the one CH3 group, here is the other one. The molecular formula, you just count your carbons and your hydrogens. Next one, CH3, CH3. So it's just two CH3 groups bonded together. For the molecular formula, you count the carbons 1, 2, C2, H6. For each of the following organic compounds, give the condensed structural formula and the molecular formula. So for the first one, a condensed structural formula means you do not show the bonds, you just write the groups together. So you have a CH3 group, there it is. CH, there it is. CH, there you go. And then CH3. And the molecular formula, where you just count the amount of carbons and hydrogens. Then for B, CH2, CH. Here is another CH, here is another CH. And now this CH is bonded to two other CH3 groups. So you can write it CH3 in brackets 2 times. For the molecular formula, you count the amount of carbons, 5, hydrogens, 10. Give two possible structural formula for the compound with a molecular formula C4H10. So now they give you the molecular formula and they want the structural formula, which means you need to show all the bonds. So it can either be 4 carbons in a chain or 3 carbons with a branched CH3 group there. Functional groups. Specific group of atoms and the bonds between them in an organic molecule that are responsible for the characteristic chemical reactions of that molecules. This definition is also in your definition video. So functional groups, the first 3 is alkane, alkene and alkyne. Alkane means there's only single bonds. Alkene means there's a double bond. Alkyne means you have a triple bond. The next functional group is alkyl halides or haloalkanes. That means you have a carbon where one hydrogen is substituted with a halogen. Halogens are fluorine, chlorine, bromine and iodine. Alcohol. That is where one of the hydrogen atoms bonded to the carbon is substituted with a OH group. Carboxylic acid. Here you have a carbon-oxygen double bond, which is called a carbonyl bond, and a OH group bonded to the carbon. But we'll get to that later on. Hydrocarbons. Organic molecule which only contains carbon and hydrogen atoms with single, double or triple bonds. So you have hydrocarbons, then you can go to cyclic carbons or acyclic compounds. Acyclic compounds can be broken up into alkanes, only single bonds, alkenes, where you have a double bond, and alkynes, where you have a triple bond.